It's really exciting to see so many of you can come. I hope you all have a good night tonight and enjoy the talk, get to know better about search and Tumblr. So before I get started, I just want to quickly give an intro about Tumblr itself. So Tumblr was founded by David Carr in 2007. It's over years gained a huge popularity as a publishing platform. As right now we have more than 160 million blogs, and yeah, it's a huge number. And it's, in terms of posts, we have more than 70 billion posts, massive content, and most of them are really, really great. We also kind of social network. People who have the common interests can connect with each other and share great content. I just took a screenshot of my dashboard so that you can know how Tumblr looks like. By the way, quick question: how many of you are Tumblr users? Wow, awesome! Thank you. Great answers. So, with such massive content, search become a very important way and very effective way to find good content you can consume. Every day we are seeing about 50 million queries from a user. But as important as it is, Tumblr search for a long time, the search functionality was very limited. From 2007 to 2012, in fact, actually up to early 2013, pretty much the only search available at Tumblr was called tag page. Essentially, for a given tag, it return recent posts. And underlying it was a huge MySQL table with tag ID to post ID and a timestamp. So when user type a query, everything converting to one single tag ID, then return the posts in the reverse chronological order. So it was very, very basic. It works okay when you search just one single tag, but anything more than that become almost impossible, especially when we have such massive content. Also, there was no easy way to find blogs. We do have a human curated directory we call Spotlight. So people can kind of navigate this directory to find blogs they might be interested, but again, this is just tiny little bit about all the blogs that we have. So in 2012, the leadership team at Tumblr finally decided to have a dedicated team to take on search and discovery because it's become so much more important with fast growth of users and content. So in July 2012, Jacques, who is also here, he's the first search engineer, joined Tumblr. Then I followed, then we Bennett, Beital, and Patrick, Adam. So together we work with the design team and the front-end team. We were able to build a set of exciting new search features from ground up in 2013, including post search, blog search, theme search, personalized recommendation, and a bunch of things. So in the next couple of slides, I will quickly walk you through what are the features available at search at Tumblr. Then I will talk about the underlying architecture, frameworks, and some of the details about implementation. First and foremost, this whole new search main page we launched last year was really bring our users' search experience to a totally new level because it not only allow you to do post search, it also gives you the very decent capability to search nice blogs. It also offers you the related terms you can search more. For the post search, there was no longer a limit on single tag. It's a full text search. It also gives you the ranked results based on the combination of recency, popularity, and also text relevancy. It allows you to filter results by post type. Post type is one very unique feature at Tumblr is that we have 7 predefined post types. It has a lot of popularity among our users. So for search, we also allow users to do that. For the blog search, finding blog is one of the top priority for Tumblr because dashboard is I just mentioned in the previous slides, we have this concept called dashboard. It's similar like Facebook's newsfeed and Twitter's timeline. Essentially, all the posts coming from the blogs you follow will appear in the dashboard. Our users spend more than 50% time in their dashboard, consume all those content they are interested. So to very large extent, the experience of Tumblr user decided by their dashboard, and dashboard decided by who they follow. So help us to find great blogs to follow is very, very important. We built this blog search. Not only you can search by name or title, we also look at all the posts published by this blog and look at the engagement of that post for related to the query you are sending. Then we decide what are the blogs really for this particular query, our top blogs, and we return to our users, and driven a lot of follows from that. We also, for a given blog, trying to compute what are the best posts so user can get a very quick preview of that. In addition to this new search, we also build autocompletes, which we feel like is not only a convenient functionality, but also is a great opportunity for Tumblr to show our user interactively what we have. Because a big problem for us is really that user to discover great content at Tumblr. We have such massive content. So when people type, we will give them this interactive autocompletes. I think it's a great way to get people more engaged. It's also used not only in the search, but also when people create a new post, they can do mention. Mention will be autocomplete, and for the tag, we're trying to suggest relevant tags when they type. We also, search is also powering the personalized recommendation. For the same priority, we want people to follow really great blogs. So we're trying to help our user by looking at the social graph, who they follow, and then we look at the people they follow, what kind of blogs they like. So we come up with better recommendation for our user. We also utilize users a little bit history activities to help user to get better blog to follow. Same thing, we do dashboard digest, which is we're trying to get the best posts in the dashboard in a weekly basis. So we send email to users. That helps get people more engaged. We also, in the 2013, very exciting, we also, in addition to all the search, we did trend discovery. So this is also another effort trying to let our user know what are the interesting content at Tumblr, and we can push to our users so user will get more engaged and they use Tumblr more. We do trending tags and trending blogs, and also you can see we create a nice charts so that our editors and sales team, they can actually understand what right now are trending, and given this trending tag, how the historical trends looks like. Last search we did was theme search. Theme is one very unique elements at the Tumblr. So we allow users to customize their blog, and the theme is people can create themes, and they can even sell themes to other people. So it's kind of like one of the commercial part of Tumblr. And for a long time, there was no way to search theme. There was a directory. You have to go different level of directory, but now we also make that searchable. Okay, so all those are kind of search features we built in 2013. Now I want to go a little bit in the engineering side, talk about how we build this, especially within a year with a team of 6, we are able to build a pretty big set of features. I think one key thing we learned when we look back, I think it's in the very beginning we built a 2 framework, which kind of like generalize a lot of commonality, common functions of different service, so that we can utilize these common frameworks to apply to different service, so reduce the development time. In these slides, it's a lot of stuff here, but if you look at in the left side, you can see essentially the 3 layers. The first layer we call the search online layer. This is a layer interact with user requests. So when users send the queries in from one of our service, either it's post search service or tab ahead, the online layer will take this request, and all those services are built on top of this search online framework, which handle a lot of common parts. Then the online layer will deal with the data layer. Data layer contains all the key data which all the service is built upon. For example, there will be index for the post search and for blog search. Another type of data is we call a signal that mainly used for ranking. All the service, they have their own ranking formula and their own set of signals, so it's also served in this data layer. Another type of data in this layer is we call a pre-computed search results, because Tumblr has very high query traffic and have lots of data, so we do a lot of pre-computation using our Hadoop cluster to pre-generate those search data so that we can really do search fast. So the third layer we call it search offline, because it's pretty much independent of user query. We can take a little bit of time to do the computation. For the offline, the two major input data, one is a more real-time stream, we call it file geyser, kind of similar to Twitter's Twitter stream. We also have a lot of batch data coming from Scoop, which is kind of copy of our MySQL database, and we also have a lot of scrap logs. Those scrap logs are more from the user activities, and so coming from our PHP app, which contains a lot of valuable information. So with these two data, again, we have a search offline framework which help to build a lot of different jobs to analyze and process those data to generate all the different pieces of data here, indices, signals, and pre-computed search results. Next slides, I will give a quick summary of the software stack, what software we're using. In the search online layer, we're using this PHP plus Edge Epoxy, Nginx, and Memcache is used everywhere for the caching purpose. Then we use iSinger for monitoring, and for Scribe to collect all the logs.
Can I ask a question?
Yes, that is always.
I'm just curious if Kubernetes and Memcache, why do you use both?
Memcache essentially doesn't have a big difference. Memcache doesn't have persistence. For Redis, we not only use as a cache, but we have a great in-house software called Rediscover. So essentially, we use that as more like distributed data serving layer. It's very scalable and it's very fast. It has a persistence. So that's the difference. And we use OpenTSDB to collect all the metrics so that we can easily see all kinds of report. In the data layer, Solr is more used for serving all those inverted index data. Redis is a great way to have this persistency to serve the signals and pre-computed data. And MySQL is where we store the main documents. So all the meta information about posts, blogs, they're all stored in the MySQL. And for the search offline, we have a pretty big Hadoop cluster, and we run different jobs written in Hive, in Pig, in Scouting, and Python, mainly for streaming. And we also have Java programs to interact with Solr to do the indexing for more real-time search. So that's the stack used at Tumblr Search. So for the search online framework, essentially, so this is one really key piece for the search online, because it kind of provides, first of all, it generalizes the search flow, the common flow into about 6 stages: the query parsing stage, the retrieving stage, and signal fetching, then ranking, then fetch the documents and do filtering. Pretty much all the services follow this kind of pattern. So we have one kind of implementation we call search base, implements all the common boilerplate code. For example, how do you do execute the whole flow? How do you pass result from one stage to the next stage? How do you do caching? We have multi-level caching application can configure how do you want caching, and how do you log all the different pieces of data, do profiling of the performance. Also, you can choose to execute your search either in the synchronous mode or asynchronous mode. Then we also have this editorial capability so that you can, based on your need, you can kind of block some of the results or inject some results. So all these are common to the search service we build on top of this framework. Each service, the only thing they need to worry about is really how to pass the query, and based on pass the query, how to retrieve a set of documents from much larger space. So essentially we call candidates documents. Then what are the signals you're going to fetch for each of the documents? Then you do ranking. So very specific to each service. Then you wrote kind of a class. By the way, this online framework right now is written in the PHP for many of the reasons, because we already have a lot of plumbing work at PHP. We have MySQL. Wow, perfect timing. Plumbing. So we choose to do it in PHP, even though it has certain limitation of the PHP. It doesn't have really true concurrency. But for right now, we are happy with that. We might want to move this out from our PHP layer at some time. And for the offline, we also build called a batch processing kind of framework. So we generalize a lot of building blocks so we can construct the jobs to process data very easily. As you can see, we have 4 types of different jobs. And the underlying, we have, for example, some very generic term generators, so we can do quickly inverted index, generate the term, and also there was a top K indexer. And we also have a repository called Lucia2, which have many classes that can be reused, which is written in the scouting. Once we written all these jobs, they can compose as a workflow with this workflow engine we built in-house. So this workflow engine will first resolve all the dependency, because each job they can depends on the upstream job, the results. It's all expressed in a configuration file. This engine will take this configuration and construct the workflow and execute. It also providing some common functionality, like it can do the versioning. Whenever it generates a new version of output, it can do the difference generated, we call it delta. So when we propagate this output to the data layer, only the difference, the delta part needs to be propagated. Usually it's only have 1 or 2% of change we really need to propagate. And because the data is very big, and it's all very important that we have this integrity check, because we don't want our users see kind of incomplete results. So we spend a lot of time to make sure we have a good verification, integrity check in the data, and have a lot of failure detection and alerts. It's all building into this workflow engine. So each individual job don't need to worry about this. So this saves a lot of development time, and also make sure the quality of data is good. So that was more about in general the frameworks, architectures. In the next couple of slides, I want to go to a little bit more details about implementation. So first thing is about indexing. Indexing is very important for search. And first question we want to answer at Tumblr in this very particular environment is that we have lots of data. As I mentioned, we have huge amount of posts. We have 72 billion posts. So how to index? If we index all of them, does that really make sense? So with a lot of kind of debating, we do a math and we realize, first of all, we don't need to implement all the posts, especially the reblogs, which is a big portion of all those posts, because we divide the posts into original posts and reblogs. So first cut is that we only index original posts. But even with original posts, if we look back to all the way to 2007, it's a lot of them. And the best we can do is we need 600 machines. Back then, 600 machines for Tumblr as startup was a huge number of machines. I mean, back then, before followed by Yahoo, right? So we did quite some design, and we end up with a solution is that we build a 3-tier index. The first tier is we call it recent. So we take last 6 weeks of original posts. We index all of them. Then we also look back 4 years. Then we have a certain criteria. We use popularity as main criteria to select, we call it popular posts. Then we also have this old tag index, which is not that great, but it still can serve when, for example, Solar failed, it can still as backup. So we have this 3-tier indexing scheme. So we were able to manage down to 40 machines, which is a big cost saving. And we did some testing in terms of coverage. We take some random queries and go back to the Hive. Then we see if we have all the post index, what's the difference? And difference is really small. Because really for most queries, we have lots of content, even in the last 6 weeks. And if really some rare queries, then we go back this 4 years with this popular post. If still you cannot serve, which means either the posts you're looking for are not that great, or we just don't have that. So, and also with this 40 machine setup, we are able to serve up to 4,000 queries per second, which is non-cached, which means go directly to the Solar cluster. Another thing we do is, because we're trying to really minimize the machines we won't use, is that we make our index very lean. We separate all the volatile signals from the index, which means, for example, the popularity, which is keep changing for posts. We don't start with the index within the index, which eliminate a lot of reindexing efforts. It also gives us a more independent way of how to implement more signals, how to store them, how to serve them. Another lean index is we don't store any text information other than the index itself. So the main advantage is that it's dropping the memory footprint of the index, because our goal is trying to fit as much as index into the memory as possible, because that's dramatically increase the performance and the reduced latency. So that's the things we do for indexing. And for ranking, right now it's still very quickly evolving. We have some decent ranking, but it's far from perfect. And right now in the production, we use a relatively small set of signals, like global popularity, which includes the counts of, for example, likes, how many people like your post, and how many people blog your post, and how many people follow a blog. This kind of global popularity. We also have this concept called local popularity. For example, in the blog search, we will look at query term, not only how many total likes of this blog received, but we also look at only the posts contain this term, and then we're trying to aggregate the likes on those subset of posts. It's kind of we project based on the query context, user and query. And also in the personalized recommendation, we also look at the user itself. We not only look at the overall follow counts of a blog, but we also look how many follow actually come from your friends. So with this kind of locality respect to exactly which user and which query. It actually improved the relevancy quite a bit. Another important signal.
How do you guys get
For the recommendation, we have this A/B testing framework. So basically, it allows to put a small percentage of traffic for a given version of recommendation. So for example, 1% traffic, then the main metric we see is called a follow rate. So for a new version, if the follow rate is better than the previous version, then we consider it's a gain. But we also break down our user into different buckets, because sometimes some versions, some algorithm may work in a particular bucket better than other bucket. The bucket we usually divide by our user, how many people they follow right now. Because this essentially, for new users, they usually follow less people. And for more senior users, they probably follow a lot of, so they have different behavior. So that's how we measure our versions of implementation. Then for textual relevancy is also very important, especially for post search. So we look at how your query matched within the post. Is it an exact match? What's the proximity of the different words? And also we differentiate, do you match against tag or some other tags? Because tag of a post usually carries better relevancy, because people spend time trying to summarize a tag they post with a good words that usually carries more weight. Then recency is also important for example, post search. So that's the kind of the ranking, and it's a big direction for us to continue to do come up with better signals and do better ranking. For the duplicate elimination, at Tumblr we have a lot of duplicate content. Some of them are because there was third-party tools allow user to do reblogging, but we don't know it's reblogging. And some of that is user, they copy the content and they just pretend these are original posts to gain their popularity. So sometimes it's very embarrassing when you do search, you see lots of almost identical content. So we spend some efforts to eliminate all those duplicates. We do two kind of duplicate elimination. One is in the index time, we're using the post signature, mainly look at the tags of a post. And also we require tags has to be more than a threshold number so that we don't really kill too much coincidentally they have same tag. This n is actually a pretty big number. In the search time, we also look at the media hash, because a lot of posts at Tumblr, they carry media information in this photo, or video, audio. So we have, for all of them, we have a hash. So for those hash, if we have certain way to match them against each other, and so we also take advantage of that to do the media level DE. Another thing we do is called a neo DE, because sometimes some posts are the same, but the people might end up with adding one or two tags or remove a few tags. So we also have a way to detect this with certain precision. The thing is that we have so many great content which give us a bit space that even we make some mistakes, we still probably have some great content to show up. Well, the cost, we're not detecting those, might lead worse user experience. So we tend to be a little bit more aggressive right now to do the DE. Also, search platform. So this is about Solar Elasticsearch or Solar Cloud, which probably there's a lot of debates, which one is better. What I'm trying to do is just see what we tried. So at Tumblr, we started with Elasticsearch. All this was actually helping us, give us some helps on solving some of the problems. But for quite some time, there was some main issues that Elasticsearch back then, the cluster forming, how do you form a class that was there? It's very like a black box. You have very little information about this, and when it works, it's great. But when sometimes when you restart a cluster, it just doesn't form, and it enters into called a yellow state. it's not red, but it's not green. It doesn't work. And our engineers usually will spend a lot of time and trying to dig in, and it's just really hard to even understand why, what's causing this. So even with, all the expertise from others, we are not able to get the bottom of it. So we switched to the Solar Cloud, because Solar Cloud also offer very good functionality in terms of the clustering, distributed search. It works pretty well until we put a lot of load. We're trying to simulate our traffic load by setting, at the same time, doing a lot of indexing, a lot of search. Then we're starting to see problems. One of the major problems we observe and we don't have a good solution is that because we do a lot of replica to offload the search traffic. And what we found is that one replica can slow down the whole indexing of the same shard. So I dig into a little bit of code of Solar Cloud. It seems the leader has keep a certain buffer. So if one replica doesn't acknowledge after a certain maximum size, it will trying to wait, and stop sending to the rest of the replica. So essentially, because every second we have thousands of posts we need to index, so easily we're causing a backlog, so that the freshness of search results are largely kind of delayed. So again, we trying to solve this problem, but with no avail. So, and we have deadline to meet, so we end up with actually go back to the plain Solar, and we wrote our own customized clustering management. And as right now, it works just fine, and we don't really see any problem. So of course, at some point, we still probably want to go back to review and test the Solar Cloud when all the glitch has been ironed out. But as for right now, we stay with this basic Solar 4 with some of our customized code. Yeah, so our take is that, and functionality-wise, I really like the design of the Elasticsearch and the Solar Cloud, all the easy needs to use, but plain Solar just seems still be a lot reliable in the production environment like us. We have, at the same time, a lot of indexing and a lot of search. Last thing I want to mention a little bit is one lesson we learned at Tumblr is we have lots of data, lots of traffic. Seems best way to really to meet both ends is if the search is not time sensitive, we should do a lot of precomputation because this really gives you the resource to do more sophisticated either processing or analysis, and you don't have this pressure. You have to, okay, you only have 500 milliseconds, go. We don't have this pressure in the offline time. Of course, the limitation is that if the application itself is real time, like the post search, you have to, especially in recent mode, you have to give use up to like a second. For example, when a user hits post, they expect their post have to show up like within a second. So for that, it's not applied, but for many other search application like tab heads, it doesn't change much. Related search is stable, and recommendation, blog recommendation, again, it's not like gonna change over a second. You want to recommend a different blog. So for all those less time-sensitive data, we do a lot of precomputation, use our powerful Hadoop cluster. So that's one important lesson we also learned when we building the Tumblr search. What's next? For Tumblr search, one big thing we want to do is we call it in-blog search. So right now, if you go to any Tumblr blog, the only thing you can search, again, is similar like the post search. You can only type one single tag. And internally, it's a MySQL table indexed with tag ID. So within that blog, what we want to do is that we want to provide a functionality. Given any blog, you can search not only original posts, but also reblogs and likes. And the difference between in-blog search to like regular search is that it only searches within one blog, so which makes a lot of things easier because when you index, you can separate the data from different blogs. So you only index one blog, create like in the Lucene, essentially they use different, they call it fields. So and innovating generated binary data format is that different fields they have totally independency. So in the retrieving time, it could be really fast. And another big thing for us to do is to improve the ranking. So we already started seeing some gaming, some spamming. They're trying to gain the popularity of search results. So we want to devise a sort of more spam resilient and more effective signals. And once we have more signals, handcrafted scoring function is not going to be that great. So we're also trying to apply machine learning to use signals plus all the user feedbacks to rank better of results. In the recommendation side, right now we mainly rely on more in the kind of a collaborative filtering side to generate the recommendation. One thing we want to do is we actually want to go more directly to see, given user, given the content, can we model the topic directly so that we can, using the topic to match between user and the content by understanding what are the interests. It could be supervised, it could be unsupervised, but essentially we're trying to do recommendation based on interest. And that would be another good supplementation to what we are doing right now. The last thing is about content discovery. Always we have more content than user can consume. So how to detect really interesting content and that user know, and so they can more appreciate like Tumblr as a big content network. What's the content they might be interested in? So that's a very big and ongoing efforts. We want to do the better efforts on the content discovery. So that's pretty much, I think, the talk. So if you have any questions, I would like to answer. And before that, as you see, we are hiring. So if you're interested about seeing all this awesome content and work on the search, please talk to me or some of my teammates. Yes? For the so the question is about schema, how do we index? For example, so right now the main data we have is the post and the blog. So between them we have different schema, but for the post, the schema is relatively simple because we have tag is one very important field. We also have title, we have body tags, we have caption, all those things. For right now, we actually only differentiate the tag and the rest of the text. So, and for them, we do some basic text analysis like subwords removal and stemming, like using the Porter 2 algorithm to do stemming. Then pretty much then we just put on a solo, then index, create an inverted index. So that's how we index them, yeah. We don't really have very complex schema. Yeah.
When you were transitioning from Elasticsearch to Solr, did you outgrow each of the previous generations, or did you try them on a prototypical basis to just find out that they weren't going to work for you?
Alice, you want to?
Maybe repeat the question.
Yeah, I will.
Question is,
Let me repeat the question, so because I think Paul is recording this. So the question is about when we move from one platform to another platform, what are the versions? Do we try different versions of this one platform, right? Is it correct?
yeah, the question was, were you using it and then it outgrew it, or were you testing it as a prototype and it just didn't?
Oh, we actually stick with Elasticsearch for quite some time. Some features with Elasticsearch actually was in production. Went live, our user actually was using that. That's why we have a lot of pressure to keep it alive and running. And that's why we actually bring artists and his team trying to really make this thing work, because we really like search as functionality, but unfortunately, with a lot of efforts, with that the version available back then, it doesn't really, for our particular application, doesn't work.
About what point did it become untenable to keep using?
It basically the failure, like almost probably every other week, either we have one major failure, which will causing the downtime of that service for a few hours. So, I mean, that's just very serious, and it seems there was no easy solution just to get rid of that with confidence that, okay, we know what's the root cause, and here's the solution, and we cannot. So, yeah, I mean, for us, we want to have the we can predict like this service is available, and if even something goes wrong, as long as we know the root cause, I mean, we are comfortable. But this like search is too many magic happen inside, so we decided to go with Solar Cloud, which definitely provides more transparency that we can see what's going on. Yeah. Hi.
How much of a factor was cost in picking solar, or did you just think it was about?
Can you repeat that again?
How much did cost play a factor in your choice of solar?
So the question is about how much the cost play into the decision to choose solar against other choice. So pretty much the cost was, we didn't see any like increase, for example, in number of machines. Performance-wise, they're comparable, I think. So the cost was not a major factor for the decision. Yeah. Reliability is really the things eventually will lead us to the solar. Yeah, yeah, please.
What about across different languages? How do you guys handle that?
So that's a good question. So in search team, we pretty much we think we are language agnostic. As we, for example, in offline we have support like different language. The key thing is we trying to build a good framework so that it can support in the very high level support the job which is written in different language or in the software. For example, we in the online we have this using Swift as a bridge to from the PHP that can talk to different service, for example, written in the Java or Scala. But I think there's also cost is that we do see those redundancy things hasn't been written. So I think it's a kind of a trade-off in the beginning because people come from different background. We need to get things done. So I think we are willing to that happen. But once we have a team and we're building a lot of things within a company, it's probably actually a good idea to consolidate the things into one or two language, because then you can reuse a lot of things. So I think we are, especially for the offline, one thing we want to try is we more want towards to the scouting because it has a lot of great properties and especially in terms of reusability and also the modular things seems pretty good for like a bigger team to work together with. So yeah. Alice.
You said in the beginning you didn't have very good search. You mentioned MySQL, right?
Yep.
And I'm curious what you've gained from building all this functionality. Have you measured anything at business level?
Yeah, this definitely is a very good question. The thing is for search, the main thing we measure right now is we measure some engagements about actually this happened only when we build a new search. So, but when we look at, because Tumblr is a great social network, so a lot of things we learn from our users is that we have certain queries we can see. Our people are very like speak out. They whatever they don't like, they will put it up on Tumblr. So for us, a lot of time when we release a new feature, we just go to Tumblr and see how our user respond to features. And of course, we are prepared. User tends to be whoever wrote posts are a little bit more probably I would say towards a little bit more negative to the new features, but we do see a lot of appreciation, especially when after we tweak the UI. Initially, because we also introduced new UI in this grid format, which is great. I personally like that more than the list because it allows you to look more and in the search results. But a lot of people, they like the list format so well, so they actually kind of like have a lot of negative comments. But as soon as we give them a choice, they can either using grid or using the list. Most people are very, very positive about new search functionality. Now they can search not only just single tag, multi-tag, they also search like full tags. So I think from that, it's a big win. And at the same time, the search volume is increased, but that's less of a concern because really, once you have a better search, sometimes you might see not necessarily your search volume will jump because they might actually, in the first search, in the first page, they already find what they want. So that's kind of like double side. But a better measurements would be engagement, which right now we're starting to report daily. But unfortunately, we don't have that number before. So moving forward, what we want to do is for the search, we also want to do like recommendation, we want to build this A/B testing framework so that we can see between different release, how are we moving this kind of metrics, like do people like more often in the search results, they follow other people's blog more often, things like that, yeah. Okay, I'll probably go this side for question. Yes, please.
You mentioned you were using Graph as the serialization protocol.
Yes.
Is there any particular reason to choose Graph over Apple?
To be honest, this thing was, so the question is about the serialization, this protocol where we choose Swift against other available ones. The quick answer is this decision has been made even before I joined Tumblr. So yeah, I think it works. Whatever it works is good. So yeah. Please, yeah.
You say that you don't know if indexing all posts. I'm interested to know what you are indexing on. If you're indexing on someone with like photos, do you get a daily post? And that indexing will be
I didn't get the second part of your question.
the thing is, if you index on someone with like photos, you would get a few billion posts.
Couple.
A billion. I mean, a couple of million posts.
Oh,
And then
okay.
the indexing would be the same thing. I mean, the choice is what you choose to index is kind of critical.
Oh, right. So the question is about how do we decide what to index, what not to index. As I mentioned earlier, right now the criteria is mainly based on popularity. We don't look at the type of content. We don't trying to kind of like police the content and see, okay, this is bad content. We're trying to index the content, then leave the choice to user. We do have option for users to say called safe search. You can see better content and like more safe content, not necessarily better, but safer content. But also if you want to see all content, you can see that. For the choice is mainly for the engineering and this consideration. So we use popularity, which means if people like your post more, like reblog more, then you get a chance we will index them. And if we have really unlimited resource, at a certain point we might just index all of them. Yeah. Please.
You mentioned before something about replicas and how it takes a lot of time to index for replicas and how to slow down the kind of thing. Got me thinking about redundancy in general.
Right.
One of the problems that you run into is managing clusters across data centers as opposed to generally within single data centers. So I was wondering, with this custom solar solution that you guys have gone with, would that span data centers or is that within a single data center?
As of right now, we only have one data center. But even with a multi-data center, I think it won't be a big issue because we still can. So essentially, we can have multiple file guys, for example. Oh, sorry. The question I want to repeat. The question is that is our this replication schema is within one data center or across data center? The answer is that right now at Tumblr we only have one data center, so the solution was within one data center. But I think it can also apply to multi-data center by easily by replicate in the file guys level. So we can have basically different consume the identical stream, and in a different data center we can build the same index, because as long as the input is same, then the index should be same. Yeah. Please.
Have there ever been days when you thought MySQL wasn't being such a good then, and things might be getting a little closer to any other tools that you think about?
To be honest, I think MySQL works pretty well in the, but and I don't have really much experience with the other database you were mentioned, but we have pretty good database team at Tumblr, and they have a lot of expertise on making MySQL work in the scale. I mean, we have huge MySQL database because we have such such massive content, So, and again, this decision was made before long before I joined the Tumblr. So we, at a certain point, we might start to review this MySQL without always working, because at a certain point, maybe it was really get to a point we need to have a better technology. But as of right now, it works pretty well. So we didn't get to the point to change that yet. I'll probably go this side take one question, yeah.
Do you do any phoneme analysis? And if not, why not? If so, which coding?
Great question. So question is about photo analysis.
Phoneme.
Oh, phoneme. Ah, okay. I thought it's photo analysis. So
We can do that one next.
we actually no. Right. The answer is phoneme analysis, and we don't do that.
Okay. Do you have any reasons why not? Or?
We just didn't get to yet. So as I said, there was a lot of things. I'll probably add that to one of our actually to-do list to consider that. Yeah.
And how about a photo analysis?
Thank you. Photo analysis actually is one very interesting area, and especially recently there was a lot of acquisition in this domain. So and the Yahoo, which is right now we under this big family Yahoo, they actually have quite a few companies they bought recently have specialized technology in analyze the photo. For example, it check the simple thing like text, but also trying to annotate the entity in the photo. In Yahoo Lab, they have something which is basically, of course, it's still right now it's research, but in the very good stages that for most celebrities, actually given the photo with pretty good precision, you might be able to identify them. That actually, because a lot of photo posts at Tumblr, they may don't have tag or very little tag, because some people they tend to publish good content without annotate them, right? So if we can actually use additional photo analysis to get more information, so that can help search a lot. Yeah. Yes.
On that note, how does Tumblr plan on dealing with untagged content? Is there, you think, foresee a way for them to generate, I guess, like tags for users or CPS tags?
So for untagged content, if it contains some other text, it will become less of an issue. But for the, for example, if the tag is only thing it contains is a photo, then there's a couple of ways. One way is analyze the photo itself. Second is maybe you go back. If there's a certain way we can know, okay, where this photo comes from. And for example, some people they will put a source of where this photo comes from. Then one option we are looking at is trying to go back to crawl that page or to find the surrounding text. So that's another approach. Essentially, it's getting more text on that. Yeah. Yes, please.
When you move to reindex, how do you build an index in the box and how we corrupt?
So the question is, when we reindex, how do we swap the new index? So for the post index, the only time when we reindex is the post changed, right? So that essentially is built in by Solr, so it will handle, like take the new content, because it will actually delete the old ones, override the old one. So that's not particularly we are worried about this. And the only time is that when we have to recycle the whole, because we said we keep releasing the 6 weeks. So when 1 week become like 7th week, so we're using Solar's this com admin kind of command. So we kind of we have in our index side, we have this policy to see once a core become out of date, we will delete them dynamically. So yeah. Yes, yes. Then we replicate them across different servers. So right now, actually, our core is every week we create a new core. So we consider shard, yeah. So for the replication, as I said, we are using plain Solar. Again, our indexer manage this replication. So the way we're doing is we split the queue. Once we read posts from FileGeyser, then we multiplex them to different replicas, and each of them are identical to each other, but they don't have any communication between them. So that's get rid of the complexity. Yeah. Yes, yes. And this is all controlled by indexer. So that makes sense. Everything we can control. We know exactly how the replication happen, how the sharding happen, and if something goes wrong, we can find the root cause and fix it. Yeah. I might go this side for one question.
So Twitter released an open source JavaScript Python plugin which allows you to fetch data cached on the client and then query against that and then call back to the server if nothing is taken there. So I was wondering if you guys utilize any client side approaches like that at all.
For the client side, for the typehead, we do cache. If you ever type this thing, it will cache for the session. But because our typehead is really fast, anything beyond that we don't do. So pretty much it only do very basic caching. So yeah. Yes, Otis.
What percentage of your content is being misused? You mentioned duplication and things like that. How much do you save by detecting those things?
You mean misuse the
Sorry. You mentioned that you detect duplicates or near duplicates because people sometimes repost.
Oh, okay, okay.
Content. I'm just curious how much you save in indexing, for instance.
For the indexing, I think I didn't remember the number. I would think it's actually in general it's not very big because we have so many content, right? The percentage I think at most it would not more than 5%. If I have to give a number, I think but it's still even 1% of the posts is gonna be huge. And also really what thing matters is in the search time. Are they appearing in the search results or not? You can have billions of content as long as they don't show up in the search, we don't care. But that's why we do a lot of auto search time duplication because that's actually really the key. We don't want the user to see duplicates when they do search. Yeah. Yes, please. So the question is about how do we consider sharding when we ranking data. So essentially right now the scheme is because we shard the data based on recency. So when we're doing retrieving, we actually give, and because recency is also important in the ranking. So right now we fetch more recent data. Only when the recent data is not enough, then we go to this called a top popular partition. Then we fetch additional ones. And then once we have this, then the ranking is pretty much similar. We combine recency, textual relevancy, and popularity. Not right now, but categorization is one thing in our roadmap. We're trying to, there's quite a few things like all the search. First, we want to do a better job on analyze the query, like detect the entities and also what type of entities, because different type of entities might have, we might need a different ranking or retrieving strategy. Right now, there is no learning. It's all handcrafted. But the thing we're looking at, most likely we want to look at things like decision tree to learn the ranking formula. Yes. Yeah. Yes. 2 more questions. Yeah, because I think we have to close the office. So, yes.
You mentioned before when doing A/B testing, you pick some sort of demographic and then push out a change, compare the results.
Mm-hmm.
You said something that the bucket that you choose is based on the number of followers more often than not, or something very strict?
So the question is about how do we, in A/B testing, what does really bucket means, right? So.
Curious as to if you bucket the entire Tumblr community, it seems to me maybe naively that the results you would get would eventually kind of homogenize to the lowest common denominator.
Right. So the question is, do we doing the right thing when we do A/B testing, when we do bucketing? I think I probably misleading you a little bit is that when we do A/B testing, first thing is that we put user into percentages. That data selection is actually pretty much randomized. We don't do any. We just trying to have a very even distribution across our whole user base. But once we get results, when we're doing analysis, not only we look at the overall number in that user we give a new version, right? But we also break down the user who are seeing new version into different buckets based on certain criteria, so that we can better understanding how different bucket users respond to this. Yeah. Okay. All right. So last question, Adam. Yeah, last one. So. All right. I think so. Oh yeah, G2. Yeah. All right.
So it was following up on the categorization. So you said you don't have any categorization of course now, or like in the sense that you have tags, but you have like a higher level.
Yes, if you think each tag is its own category, we have something, but we don't really differentiate that much right now. For the categorization, we're starting to work on the trending detection, so we're trying to categorize different trends, but that's pretty much it. We will do more on that side. So I just want to let you know, we have a great bar close to the company, Hardings, and some of my teammates, Adam is over there, and Bennett, they're going to go to the bar, and if any of you have interest to hang out, you can find them. I have to go home. I have 2 kids, so sorry. Yeah, and thanks again for coming, and hope you enjoy the talk.